Using functions to model relationships, example number 6. Lacey is hiking down into a canyon. The table shows her elevation above the canyon floor at different hours during the course of the hike. Write a linear function that models this situation. Identify the initial value and the rate of change of the function. This problem is extremely important. Please make sure that you pay close attention to what I do here, because there's 4 parts to it, and the next set of notes we do has a review just like this that is graded, so you're going to need to know how to do it there. This is on the review, it's in the homework for this lesson, and it's on the test. So please make sure you're paying attention, and if you have any questions, don't hesitate to ask. Okay, so she's hiking down into a canyon. So if you can picture this, she's at the top of the canyon. So that at the top of the canyon is her maximum height. That's the highest point she's going to be. And as she hikes down into the canyon, by the time she reaches the bottom, her elevation will be 0. Because once the elevation is measured by the bottom of the canyon. So the base of the canyon, the floor of the canyon, is 0. And then at the top of the canyon, that would be greater than 0, and it's going to be her maximum height, her maximum elevation. Anyway, so we're going to write a linear function that models this situation. So we're going to write an equation. So in order to write an equation, we have to find our m and b. We have to find the slope and the y-intercept, which is the rate of change in the initial value. So let's pick these 2 points and these 2 points. So 3,150 minus 4,200 is actually negative 1,050. 2.5 minus 1 is 1.5. There's not a lot of space, so let's write our rate of change up here. So the rate of change is negative 1050 over 1.5. Divide that out, and you get negative 700 feet per hour. Negative 700 feet per hour. So that means that Lacey is hiking down the canyon 700 feet per hour. She's going down the canyon. She's descending down at a rate of 700 feet per hour. Her initial value. Well, to find the initial value, we're going to do that the same way we did, and I believe it was with example number 3, where you take the value of y when x is 1 and subtract the slope. So if you look at your chart, right there is the value of y when x is 1. Let's go ahead and put that beside the 4,200. We're going to take that value and we're going to subtract the slope. Now you got to be careful, the slope is negative. So you're not going to just do minus 700, you have to do minus negative 700. So our initial value, go ahead and put down the value of y when x is 1 minus the slope. So that would be negative, 4,200 minus negative 700. So that ends up being addition, because remember, the elevation when she starts is the highest. So the number you get here has to be greater than this first number in the chart. It has to be greater because it's the highest point of the canyon. So that would be 49,000 feet. Now I know it's harder for you because you don't have the luxury of choosing. Oh wait, you can because you're on Notability. But I would choose white, and then over here I would put a 0 under the X column there, and then put 4,900 under the Y column. All right, so now we can write our equation. Our function for this situation would be y equals, the slope is negative 700, and the y-intercept is 4,900. So that is part A of the problem. Part B, what does the initial value of the function represent? Well, I've been saying this over and over again. The initial value is this 4,900 feet. That's your initial value. And that would be the elevation at the top of the canyon. That would be your elevation at the top of your canyon. So let's write the elevation at the top of the canyon. Your elevation is your initial value is the elevation at the top of the canyon. Now it's important that you remember that because, guys, like I said, the problem's going to be just like this on the worksheet. It's going to be like this on the next review for the next set of notes. It's going to be on the review for the test, and it's going to be on the test. And that's going to be the answer. It's going to ask you, what's your initial value? Your initial value is the elevation at the top of the canyon. Okay, what does the rate of change represent? What does this negative 700 feet per hour? Again, I already kind of discussed this. That is the amount of feet she descends per hour. So Lacey starts at the top, and she's at 4,900 feet. She descends 700 feet, and then after an hour, she's at 4,200. And then she descends after, and so forth. Each hour, she's descending 700 feet per hour. So the rate of change represents the number of feet descended per hour. The number of feet descended per hour. Okay, last part. At what time will Lacey reach the bottom of the canyon? Well, this is what you got to know. If Lacey is at the bottom of the canyon, what do you know? You know that her elevation will be 0. If Lacey is at the bottom of the canyon, she's at the base of the canyon, at the floor of the canyon, that means her elevation will be 0. And so your elevation is your y coordinate. So if her elevation is 0, we know that y equals 0. What you're going to do is you're going to take this equation that we got in part A, and we're going to plug 0 in for y and solve for x, because x is the number of hours. So y equals negative 700x plus 4,900. Plug 0 in for the y. And solve for x. There's 2 ways you could solve for x. You could do like we've done since the beginning of the year, where you box the x term, take the 4,900 to the other side, and so forth. But because there's a 0 over here, I can actually take my x term to the left. And that's what I like to do, only because I like to have my x term be positive. So I'm going to add 700x to both sides. Let me move this down just a little bit. So I'm going to add, I'm doing the inverse operation since it's negative. I'm going to make it positive. I'm going to add 700x to both sides. All right, so this will cancel out. And now we have 700x equals 4,900. Last step would be to divide both sides by 700. These would cancel, and you would get x equals 4,900 divided by 700 would be 7. So Lacey will reach the bottom of the canyon in 7 hours. Lacey will reach the bottom of the canyon in 7 hours. All right, guys, that is it for your using functions to model relationships notes. A lot of the stuff we've done in this set of notes is really no different than stuff we've done before, just maybe has a different spin on it. So if you have any questions, please don't hesitate to ask. Thank you.